Can you guys online hear me? Can you hear me?
Yep.
Oh, okay, great. My computer, my desktop kind of died this morning in class. So I'm just solely using the iPad to teach my beautiful agenda for this crisp, beautiful fall day. I cannot project it because it was on my desktop and I didn't have time to do it. So my agenda is going to be handwritten and pretty ugly. So let me take attendance real quick and then we'll get started. Okay, so let me start out with this then. Here's our agenda for today. I know it's sad, but I did the best I could given the circumstance. We're going to wrap up section 2.8. So if you have any questions in section 2.8 or concerns, let me know. And then what you're going to do is I posted the full chapter 2 review just moments ago in your Canvas. And you had done, I think, 1 through 12 or 13, something like that, a couple weeks back. And what you're going to actually do now is you're going to do from, I don't know, where you stopped to the end. All right. And we're going to go over the whole thing on Friday. And I'm shooting for a test next Friday. We need to get out of this chapter and get moving on. So next Friday, I'm shooting for the test. Okay. Not this Friday, because there's too many kids who are testing or don't know if they're testing, and the list goes on and on. So just to, take off that extra stress, we'll deal with it next week. So anyway, that's going to be our agenda. Thursday. Okay, so sorry. Yeah, I keep thinking isn't today day 2? It's Wednesday. Okay, so ooh, that's terrible. Thursday then, next Thursday, which in my mind is even better. So Thursday, not Valentine's Day. Okay. All right, so are there questions on the 2.8 homework? 18. Anybody else online or in class?
We do 16.
Yep. Others? Anybody else? Anybody? So just 2? Okay, so what I'm going to do is I'm going to open up my book and I'm just going to use a blank piece of paper and, oh, no, I can't. I'm going to need the graphs, aren't I? Okay, so let me go into section 2.8 here. And here we go. Okay, so we're going to start with number 16. And if you think of anything else that might come up, you know, that you forgot to tell me, just let me know. So I'm going to make the graph big, and I'll use the book for the questions. So 2.8, here we go. Okay, so in number 16, you have this graph, and you have a bunch of questions. You have K sub-questions here. And in part A, they want to know, is F continuous on the interval from -3 to 5? What do you think? Is it continuous? Now, in case you can't see it online, this is a hole right here. That's a hole in the graph. So is it continuous over the interval from -3 to 5? No, why not? Because what? Yes, proper, always proper. Uh-huh. Uh-huh. No, you were on the right track. I gotta let somebody in, so bear with me. Okay, so in order for this function to be continuous, three things have to happen. The limit has to exist, the function has to be defined at the point, and the limit of the function at that point has to equal the output value of the function at that point. Does everybody agree with that? So the first thing we would think of is, okay, this thing looks pretty continuous everywhere, no holes or breaks or anything, all the way to here, and then we say, oops, we've got a hole right here, right? So we can't just say, no, it's not continuous, or it's discontinuous at x equals to 3. We have to justify why. So first of all, we would say that the limit as x approaches 3 from the left is equal to what? What's the limit roughly as x approaches 3 from the left? About 2.5, you guys think? Okay, so about 2.5, we'll say. And the limit as x approaches 3 from the right of this function is, well, if we come in from the right-hand side, what's the limit or the height? 2.5, the same number, right? So does the limit exist? Yes, we can say the limit as x approaches 3 of this function exists, and it's 2.5. Is that okay? A little bit bigger. So is everybody in agreement with that, either online or in class? We cool with that? All right, the other question is, or the second criteria is the function defined at x equals to 3? Does f of 3 exist? Well, what is f of 3? F of 3 is right here, okay? So f of 3 is 4. So the function's defined, right? The third criteria is does the limit as x approaches 3 of this function equal f of 3? No, they're not equal. So this is what we would have to say. This is the reason why it's discontinuous at x equals to 3. Is that okay? All right. Now that that's established, let's look at the next question. In part B, it says, does f have critical numbers? Explain briefly. So what do you guys think? Does f have critical numbers? Critical numbers occur when the derivative is equal to 0 or does not exist. Where? Okay, at x equals to 0, it's a critical number. So at x equals 0, I'm going to be bad because f prime of 0 equals 0, right? Or sorry, does not exist, right? F prime of 0 does not exist. And what was the other one you said? At x equals 2, and that's because f prime of 2 is equal to 0. Now, there's a trick here. What about at x equals to -3? If I draw a little tangent line right here, it's vertical, right? So that means that the derivative will not exist. So it's also a critical number at x equals -3 because f prime of -3 does not exist. So whenever you have these really steep parts of a graph, chances are your slope of your tangent line is going to be undefined. And if it's undefined, then the derivative can't exist. So that looks like about all of the critical numbers, those three places. In C, they want to know on what intervals is the derivative positively valued. So on what intervals is f prime positive? Well, we know that the derivative will be positive when the graph of f is increasing, right? And it looks like the only place this graph is increasing is from 0 to 2. So we'd say from 0 to 2, f prime is positive. Questions so far? Okay, on what intervals is f prime increasing? Well, we know that f prime is increasing when f is concave up, right? And there's this slight, well, it's not a slight change, but this is concave up. And right around here, it changes to concave down very slightly. And then the rest of the graph is concave down. So the only place or the only interval for which this function is concave up is from -3 to about, I'm going to say to -2 because it's an easy number. So, right, the concavity changes somewhere at that point, right around that point. Capiche? In E, the question says identify any inflection points. Well, when do inflection points occur? Yeah, points of inflections occur when the concavity changes. So delta apostrophe S means changes, and the concavity changes at about x is equal to -2, right? Again, it goes from concave up to concave down at that point, roughly. So that would be the answer. G is f, oh no, I missed one, hang on. The limit as x approaches 0, so let me erase this. The limit, oh, I got a new line on my computer. The limit as x approaches 0 of f of x is equal to what? Does the limit exist at x equals to 0? Yes or no, does the limit exist? Yeah, so you're nodding yes. So the kids in class are nodding yes. You can't see them, those of you at home. And yeah, the limit is 0. If we come in from the left, the limit 0, or the height is 0. And if we come in from the right, it's 0. So therefore, the limit as x approaches 0 is definitely 0. So that's a good thing. In part G, says is f continuous at x equals to 0? Explain briefly. So is f continuous? Well, let's see. Does the limit as x approaches 0 exist? Well, we just found that, right? Yes, this is true. The limit exists. Is f of 0 defined? What is it? 0. And does the limit as x approaches 0 of this function equal to f of 0? Yeah, the heights are the same, right? So yes, it's continuous at x equals to 0, and this is how you would explain it. So when you explain an AP, you have to explain using mathematics. You have to, or you're not going to get the credit. Casey, are you okay over there? All right, just making sure you weren't taking a snooze break. Although it's a beautiful day just to go home and open up the windows. It's so nice outside. Isn't it beautiful? Me too. All we need is snow. Yeah, I don't know. I'd like it to get to like -40. It's brutal, but it's nice. What's the lowest? What's the lowest temperature? You're such a Floridian. Mhm. All right. I don't like the humidity here. That's the one thing I don't like is the humidity. All right. H is, so this is interesting. In part H, it says the limit as x approaches to of f prime of x equals. What does this mean? The limit as x approaches to of the derivative of f prime of x. Exactly. It just means what is the slope of the tangent line when x is equal to 2? Well, what is the slope of the tangent line when x is equal to 2? 0. So nice and easy. No work to do, right? We just have to answer the question. Okay, so just be careful with that. And the reason why is because you've got f prime right here. So we're talking about the slope of the tangent line at x equals to 2. What else do we have here? We have, oh, okay, the next one, I want the eraser. The next one says the limit as h approaches 0 from the right of f of 0 plus h minus f of 0 all over h. What does this mean? Yeah. Yeah, this is what is the derivative of this function at x equals to 0, right? From the right. We want to come in from the right. So all you have to do is go to the right-hand side and draw a little tangent line to the right of 0 and estimate it or approximate it. And I would, quite frankly, do this probably kind of sloppily because you're doing the best you can do, but I would choose the point, say 0, 0, because it's there. And then, well, there's not any really nice point close by. So maybe I'd choose the point 1/2, 1-ish. So I know that's not quite a half, but you know, I don't want to get too technical. And remember that if I draw a little secant line between them, it's pretty much going to superimpose itself onto the slope of the tangent line. They're going to be roughly the same. So I just say the slope of the tangent line is approximately 1 minus 0 over 1/2 minus 0, or about 2. All right? Yeah. You extended it this way? Yeah. You could do that. Yeah. What number did you get? Maybe it's right. Maybe it's more like 3, but 2 is close enough. That's fine. Yeah. Yeah, you could definitely extend it through some, like maybe here or something, and use those 2 points or whatnot, or use those 2 points, whatever you wanted to, any 2 points on the tangent line. It's a guesstimate, the best estimate you can do. And so 2, 3 is fine. And then so our slope's about 2. And then in the next problem, it says the limit as h approaches 0 from the left of f of 0 plus h minus f of 0 over h. So now again, we want the slope of the tangent line to the left. And again, we could probably use this point 0, 0 and, extend it this way, or maybe it goes like through there and use the point 1, -1. And again, I don't know what the number is. What did you guys come up with? 4, -4. Maybe it's true. Really? Yeah, well, again, maybe that's right. So even if we use the point -1, 1 and 1, -1. We'd have -1 minus 1. So that's -2 over 1 minus 1 is 2. So yeah, I'm looking at like a -1, -2-ish. And let's see what George says on that one. So 2.8, number 16. Oh, that's not the right section. It says 2.8. Oh, here it is. Okay, this is weird. 2.8. Oh, here we go. Okay, so George is saying that the slope on that one, and that was J. J. He's got about -2.5. So you were closer than, well, maybe not, than I am. What I know though is that it's a negative number, right? It's a negative number. And the idea is since the slope on the left is not equal to the slope on the right, these, one's positive, one's negative, they're not the same numbers, then what do I know about the derivative existing there? It can't, okay? And that's why, because it's a cusp. So the final question said the limit as x approaches 0 of f prime of x. So rather than just saying what's the derivative at x is equal to 0, they're writing it this way, which means the same thing, and we would say it does not exist. So that's 16 in the nutshell. Any questions on that, on any part of it? Anybody, anything? All right, so we'll move on to 18 then. Beautiful graph. And guess what? It's the same sort of questions here, right? Just a much different graph. And AP loves these graphs, so you're going to see lots of them on the AP exam. I also had some beautiful bell works for you guys. The problem is that I have this, I don't know what you call it, file, electronic file that I purchased from AP years ago. It was very expensive. And it contains all of the multiple choice and FRQs from 1969 all the way to 1997. So I just go in there and find a particular topic and copy and paste it into a PowerPoint. Well, the file's too big for me to like put it in here. So anyway, I'll see if I can figure a way to make a couple of PDFs and get some in there. But just in case this ever happens again with the computer, because I definitely wasn't expecting that this morning. So anyway, we'll do bell works on Friday. So question number 1, is f continuous on the interval from -4 to 4? Yes, no, maybe. So how are you guys doing online? You okay?
Yeah.
Okay, because you're being very quiet, very quiet. I'm going to start calling on some of you now. So let's see. Who can I call? Who are you going to call? Jaden. Jaden, are you with us today? Jaden. No answer from Jaden. Chinmay. Is f continuous from -4 to 4?
No, because there are holes and there's breaks in the graph.
Okay, good. So on your AP exam, would you say that?
I would say there's a hole at -1, +1, and +3. Miss, one second. Miss Wilson. I know, I'm trying to get it. Miss Wilson, you're not sharing your screen.
You guys still in the room? Hello?
Yeah.
Oh, okay. All right. Sorry. I don't know. Something weird happened with the big noise and I don't know what that was all about. But let me go back to this. And so, yeah, you would definitely say, so she said that at x equals to -1, there's a hole in the graph, and clearly there's a hole in, sorry, I got to share my screen. Clearly there's a hole in the graph at x equals to -1. And hang on a second because the wheel's spinning. I don't know if that means I'm sharing. I guess I'm sharing. And it looks like somebody's back in the waiting room. No? Okay. So what's going to happen is you're going to have 2 videos posted today then because the one that cut off. So there's clearly a hole, but does the limit exist? Yes, the limit from the left equals the limit from the right. The heights are the same. Is f of -1 defined? No. So the reason why it's discontinuous at x is equal to 1, because you see over here it says justify briefly, is because f of -1 is not defined. Okay, so you would say, you would write something to the effect of, you know, f is discontinuous. I'm going to abbreviate it, but you're not allowed to. At x equals -1 because f of -1 is not defined. You see, so you're writing a little statement, you're backing up your answer. And then she said at x is equal to 1, so why is it discontinuous at x is equal to 1? Asa. He's testing? Okay. Divyani? Vivian. Vivian's here. Why is it discontinuous at x equals 1? Yeah. Yeah. So what she just said, in case you couldn't hear her because she talks very quietly, the limit as x approaches 1 of this function does not exist, right? Why? Because the limit from the left is +1 and the limit from the right is -2, and they're not equal, so it can't exist. In, let's see, oh, and at x is equal to 3, does the limit exist? Yup. Is f defined? Yup. Does the limit equal f of 3? Nope, right? So this is discontinuous here because we would say, so I'm just kind of speeding it up a little bit, the limit as x approaches 3 of this function does not equal f of 3. Are there any questions?
So we're supposed to remember all the limit rules for the test.
Oh, yeah. It's 3 rules. Limit has to exist, function has to be defined, and then the limit at that value has to equal the function output value. Go back and watch the video. And it's on there. All right, the next question is B. Does f have any critical numbers? Explain briefly. And so critical numbers are where the derivative equals 0 or does not exist. So Deason, can you tell me where the critical numbers are?
-1.
Good.
1.
Good.
3, maybe. I'm not sure about
Um,
well, 3.
Endpoints are special, and we're going to leave those. Yeah, 4 is an endpoint, but at 3, that would definitely be a critical number. If the point is defined, but if the function is discontinuous, we can't have a derivative there, right? So if there's a hole in the graph, The limit will exist, but we can't have a derivative at that point. What about x equals to 0? Is that a critical number? Yeah, that too, because the derivative does not exist at 0, right? Again, because the derivative on the left would be a negative number, the derivative on the right would be a positive number. And as we get closer and closer and closer to that little cusp, it's just going to oscillate back and forth. It can't make up its mind. In C, on what intervals is the derivative positive? So when is f prime positively valued? Casey. So f prime is positive when what? What did you say? I couldn't hear you.
Sorry. Right. So prime is positive when f is increasing. Right?
Good, right. When f is increasing. So what intervals would you say that is?
-4 to -1.
Yep.
0 to 1.
Yep.
1 to 3.
Good. 1 to 3 and 3 to 4. And the reason why we don't just say from 1 to 4 along here is because we have this hole right here. All right, so we break it up into 2 separate intervals. Very nice. All right, the limit as x approaches 3 of this function. So let me see. Nick, what's the limit as x approaches 3?
It would be 2.
Beautiful. It's 2, right? We find the height from the left. The height from the right is the same height. So that's the limit. What's next? Is f continuous at x equals to -1? We already said, right? The function is not even defined at this point, so we won't repeat it. Okay, so the limit as x approaches 2 of f prime of x. So again, that means what is the derivative or the slope of the tangent line at x equals to 2? So if I come over to 2 and I draw a little tangent line, what I want you to always remember and never forget, because you're going to use this a lot, is that the derivative of a linear function is the slope of the linear function. So this little piece right here is the line y equals mx plus b. I don't know what the slope is, right? So whatever the slope of this line is, the tangent line, or the slope of the tangent line is going to be the same, right? Because the tangent line is concurrent or coincident to this line. So anyway, all you would do is pick 2 points on this line. So maybe the point 2, 0 and I don't know, 1, -2, and say, you know, m sub tan is -2 minus 0 over 1 minus 2. So it looks like it's positive 2-ish. That okay? In G, so we're going back to the same kind of deal here where we've got the limit as h approaches 0 from the right of f of 0 plus h minus f of 0 all over h. So again, what is the derivative as x equals to 0 from the right? Well, I compute the slope of this line. And the slope of this line, let's see, we've got the point 1, 1 and 0, -1. So it's -2 over -1. So the slope here is about 2. And the limit as h approaches 0 from the left of this function, I'm going to compute the slope, the purple slope here. And again, I might use the point 0, -1 and -1, 1. So I've got -1 minus 1 over 0 minus -1. So it looks like a -2. And so therefore, the derivative can't exist, right? Any other questions from this section? It's a very important section. Very important. All right, so if there aren't any more questions in this section, then what we're going to do, somebody at the door? No? I thought so too. But you know what? Sometimes that door at the end of the hall, when people open it, it creates like a wind vortex or something and it rattles the doors. Thank you, Vivian. Sorry that there was nobody there. So if we're good on this, then I'm going to have you guys for the rest of the class work on the review. All right. And I'm going to be here to help you if you need help. Now let me show you. Oops, that's not what I wanted to do. Where did it go? Oh, here it is. Is it here? Yes. Okay. So you guys had done, and again, I forget, 1 through. Okay. So what you should have finished was 1 through 13 the last time, right? That should look familiar. And we haven't gone over that really yet. So what you're going to do is 14 through. Oh, and you can get rid of 18E. Remember the IVT, the EVT, and the MVT, those are existence theorems, and I teach those all together at a different time. So you don't have to answer anything that involves the intermediate or the extreme value theorem. And it's 20, yeah, so you're going to do 14 through 20, and the answer key is on the last page, so that way you can check to make sure you got the problem right. Now, I know some of you copy work. It's obvious because when I'm grading papers, some of you have the same exact answers in the same exact place. Everything is the same exact as somebody else's paper. And that's fine. You know, you're in a pinch, you want to copy your homework so you get your 10 points. I really don't care about that. But what I care about is your test performance, because remember, the AP exam is all about your performance in competition with everybody else taking that test. So, and the same is true in the tests in my class. So you can copy something like this, but you're going to have to demonstrate as to how you came up with those values on a test and in your homework. So, you know, it only hurts you if you just copy and you don't know what you're doing. I would rather you say, hey, I don't get this. Can you do another little mini lesson or help me or whatever? And I'll be more than happy to do that because I want you to succeed. All right. So try not to just, you know, fill it in real quick because it's due and ooh, do the work. All right. And check your answers to see if you're on the right track. And if you're not, let me know right away. All right. So I'm just going to leave this up here, I guess. I don't know, should I shut down my computer again or should I just leave it or?
Still doing that.
It's just blinking.
You can type in a hard reset, so just like on the power button on the computer, just press it and hold it until it shuts off.
I did that already.
And you turn it on.
And then I got a black screen with a little blinking line for like a half hour. And then now it says client Mac ADDR and it's just blinking. And I don't know if Mrs. Graham got my emergency. Oh, what room she did. Shoot, I always forget to put my room number. Sorry. The bell rang and I was frantic. I was frantic. I'm still frantic. Yes, I'm still having problems. I love Miss Graham. She's just like, bam, right there. Every time. I don't know why I didn't hear my Microsoft Teams ding. The notification. I need to sit down one day and learn all about notifications on an iPhone and all that stuff because I'm really bad about it. And there's a lot of things I don't understand.
There's the one app called Tips on there where you can just go in there and it has tips on different things for the phone.
Really?
Yeah. It's like
I should do that one day. Tips.
It's automatic.
Posted to Canvas?
I'm sorry?
This file, is it posted to Canvas?
Yeah. Maybe I forgot to publish it. So I'm gonna have to go to the laptop to do it because I can't post things in Canvas from the iPad. Isn't that weird? I can grade. I can't even look at your grades from the iPad. I can grade your papers, but I can't go into the grade book on the iPad. It's just, I guess the way the app works.
The reviews up on the assignment submission itself.
So let's see. Oh, do you see it?
Yeah.
Okay.
It was just, it wasn't in the module, it was in the.
Right, yeah, and the assignment. Sorry.
Line number 14.
14 through 20. And yeah, don't do anything that says extreme or intermediate value here. 14 through 20. And we're going to do chapter 2 test. Next. Thursday. Then you're going to get into some really easy and fun stuff. Derivative rules. You don't have to take that limit anymore. Well, you will, but not very often. By the way, you know, as you're doing these things, if there's a section in chapter 2, like a whole section, or maybe more than one section, that you think, ooh, I really didn't get that, or I struggled with that a lot, you know, mark it down and send me an email. I'm so inundated with emails, I'm starting to print them off, go buy them, because I get like 1 million emails a night and I can't keep up with them. So please do that, and I'll be more than happy to spend time reteaching or doing whatever it is that will help you. Okay, so Robin.
Come early in the morning, like you said, we have to.
You can.
notify you before.
Yep, so remember, Tuesdays is a non-day for me because we have meetings starting at 7:15 in the morning until the bell rings, because God forbid if we get a bathroom break. And so Tuesdays are off limits, but yeah, generally any other day. I'm usually here, I would say anytime after 7:30. I usually get here a little bit after 7, but then I need time to set things up and, you know, prepare for the day.
Myself, your homework when you're late.
I'm sorry,
When you're late with your homework, do you automatically get like 30%?
I get 0.
I get 0.
I don't take late work. Yeah, I have, now if there's a serious situation, you know, where you couldn't really help something, like I have one kid, transferred in a little bit late, did the work, but when they transferred to another class, to one of my other classes, the work, you know, goes away. I mean, I can find it, but anyway, when I graded the assignment for you guys, I had given the kid a 0 and said the assignment wasn't submitted. And he's like, Ms. Wilson, I did it in the other class. And so I had to be reminded. And the problem is that, you know, a couple of weeks ago, a whole bunch of kids got moved around, and even a whole class of kids, and then were moved right back. And so my world has just not been the same. I'm trying to take care of all of that. So, you know, there's exceptions to the rule, but very few. And that's because I need you to become very responsible. Not really. I mean, they do, they can, and they should, because a derivative can't exist at an endpoint. But a left hand or a right hand derivative could. So is there a thing that you're working on where an endpoint's given? Yeah. So for A, you could only do a right-sided limit, or yeah. So yeah, endpoints derivatives can't exist at, so technically they can be considered critical numbers. You have to do that on your own time. I need you to do your calculus. Do your calculus. Calculus avoidance. You see how that works? Let's see. I'm going to go. So I'm going to stop sharing my iPad that way. I can look at my participants list here. Wade, you doing okay? You doing all right, Wade?
Yeah.
Okay, just checking. Miss Graham didn't come. She's not here. I am in room 236, right? Yes, that's my room. Okay, Rebecca's here. Victoria's here. Is Ellis here? Ellis. Ellis is here. Ashlyn is not here. Jemiah's here. Rebecca's here. Alex. Does anybody know who Alex Evison is?
Yeah, he's in my engineering business.
Do you know where he's been? I haven't seen him, it seems, online for a while.
He was online in my second period class last.
No, I'm talking about in my classes.
I have no
Like
idea.
he's absent today. He might be testing, but
Oh yeah, I think he is.
yeah, when I can get into, actually I can get into first class from my iPad, I think. So I can look at the roster and see who's on the roster.
I know that roster for like testing is super messed up.
It's been pretty good.
Because I was on it yesterday,
Mm-hmm.
and so were like a few other like in-person students, but we already took it. And then like some people that didn't take it were on.
Well, it doesn't surprise me, to be honest with you. Doesn't surprise me. Conference night links. Yeah. I'm doing my conference night from home tomorrow because I don't have a choice. Middleton roster 9:30. So let's see who's on it. Oh my gosh, there's so many kids on it. It's like 1,000 kids on this roster. OMG. Okay. So Ace is on it, so he's good. Oliver's here. He's here. You said Devyani's testing, right? Yep. Vivian is here. Nathan is here. Gabriel. That's interesting. Is Lily with us today? Yes, Lily's here. Leo's here. Okay, so how do I pronounce this name? Akhilesh? 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 Okay. And Dia's here. Derek's here. Jason, Casey. Nick Miguel is here because he answered a question. John Wells, Dot is here. Okay. HIJK. Do you guys know when this whole testing scenario is like over with? Like
I think this is the last.
this is it for testing?
Until like April or March.
Good.
Some people are testing Monday, because they had Tuesday, Thursday, and they had one more day.
No, they're combining reading sessions 1 and 2.
Oh, they are?
I feel so bad.
Yeah, I proctored yesterday, and so one of the kids said to me, can I start session 2? And I was like, what? This is session 1. They're like, no, we were told we could do session 1 and 2. And I'm like, I know nothing about that. So anyway, I finally figured it out. Miss Wilhelm got back with me, and she's like, yeah, they do both sessions. So I don't know why they couldn't have done that last week. Everybody would be done by now. Anyway,
Number 15 on the review,
yeah.
once you sketch a graph where G is continuous.
Okay. So let me share my screen and let me go into, you said 15. So that's sketch a possible graph of a function G that is continuous on the closed interval. So let me just write this down. So from -3 to 2, such that G prime of -1 does not exist. Now there's going to be many different variations of this graph. For all x where G double prime exists. And did George give you a picture or not? Because there's going to be so many variations, and this is it's hard to do these kind of things. You'll never have something like this on a test, either AP or in my class, by the way. It's just an exercise to kind of make you think. But so let me just get a blank piece of paper here, and let me go turn on my projector up front so that way you guys can see it. I know you're not all on. Why aren't you doing your work? Assignments?
Oh, it's on modules.
No, because it's an assignment. Thanks. Yeah, you should have paper out, a pencil out, a calculator out, and a cloth to wipe your desk. All right, so I wrote down the criterion. We want an interval from -3 to 2, so I'd probably, I'd call this -3, I'll call this 2. G prime of -1 does not exist, so G prime of -1 DNE. G prime of 1 is equal to 0, so it's a flat slope. So that means that I'm going to have a bump on the graph, right, of my graph of G. G double prime is negatively valued for all x where G double prime exists. Okay, so at x equals to 1, so -1, -2, 1. I'd probably start over here at x equals to 1. Reason being is because I know the derivative is going to be 0, so I'm going to have a bump. The bump could go this way, right? It could be a minimum or it could be a maximum. G double prime is negative for all x where G double prime exists. So where the second derivative exists, so what that means is that the graph has to be concave down for all values of x where the second derivative would exist. And that means pretty much everywhere. So at -1, 2, the derivative does not exist. So that means the second derivative wouldn't exist at that point. So I don't know, maybe at -1, maybe at -1, maybe you'd want to put a hole somewhere there.
The graph has to be continuous though.
Well, it can be continuous everywhere. Let me see. Sketch a possible graph of a function that is continuous on the closed interval. Yeah, it does. Well, then it's impossible.
Put a corner.
Yeah, thanks. Corner. Corner's good. A cusp. Where's my paper? Here. All right, so yeah, a corner, sorry. All right, so maybe we've got a corner here. And, you know, maybe it looks something like this. G prime of 1 has to be 0, so that's taken care of. G prime of -1 does not exist. We've got a cusp there. The function is continuous. All points are defined, right? The limits exist for all points, and the function is, the limits for all the function output values is the same as any limit that we take, right? So maybe something like this. But a lot of thought goes into making that sketch, right? So, you know, your sketch might look different. Maybe your sketch looks, you know, like, I don't know, like this or something like that. I mean, there's a bunch of different ways you can graph it. So don't be too caught up on that because I'm never going to test you on that, and neither is AP. They will never test you on something like that. Oh, I got a new line. Maybe Mrs. Graham's working remotely on my computer. Oh, so let's see. I can get the graph from here. And you guys can chit chat while you work, you know, it's okay. And you can help each other too if you want to. You just can't get too close to each other. In this very strange time in which we live. First class error, of course. There's a first class error. Mm-hmm. 16A. Yes. So you're going to have to find the first derivative and the second derivative, so that way you can plug the values 0, 1, and 2 in to get the value for velocity acceleration. The limit definition. what I'm trying to do is find little tablets for in class, like a class set. So that way, if I buy them, I can put up the whiteboard and you guys can all work in the whiteboard from the tablet. Now that's not going to help the kids who are at home, but maybe when we all return back to school, if that day ever happens. What's this? And then the whole class can have, everybody can have their own tablet to work with. Okay, can they ever get to the point and tell me the name? So let's see. So, yeah. So I'm going to try and write a grant for like $36,000. And that's if I get the grant. Grant writing is hard because if you don't dot every I and cross every T, then you don't get the grant money. But the grant money you get to use if you have a particular purpose. And my particular purpose is to make it so that all of the students can be interactive and visual learners, whether they're in or outside of the classroom. And that's what I'm going to buy the tablets with. And the best tablet's the iPad, let's face it. So that's what I want. I want the best. I'm just that way. Any questions so far? You guys online are being extremely quiet today, unusually quiet, and that concerns me. Let's have a conversation, e-learners. First and foremost, how are we doing with the homework? How are we doing with the review? So for instance, Ashlyn, how are you doing if you're here? Ashlyn's absent. So Ellis, how you doing?
I think I'm doing all right.
You are? What number are you on?
Let me see. Take a break for a moment.
Breaks are good. But you don't know what number you're on?
Say it again?
You don't know what number you're working on, even though you're taking a break? Like the number you ended with before you took your break?
Oh, I think I was on number 5.
Number 5?
I
Okay.
think.
You were supposed to start at number 14, but that's okay. You want to do number 5? That's great.
I didn't do the other ones yet.
Okay. Victoria, how you doing?
I'm doing okay.
You're okay?
Yeah.
All right. Is Chandrika here? I don't know if she's here or testing. Chandrika, are you here? Participants. She's here. Are you with us, Chandrika? I'm sorry. Who else? Derek, how you doing?
I'm doing fine.
You are. You have any questions?
No.
No? Okay. Dia. She's here.
Yes.
How are you doing?
Okay, do we have to finish this by the end of class? Like if we have like 1 or 2 left, can we do it after?
No, that's fine. The due date's not until Friday, I believe. Just as long as you get it done by Friday, that way, you know, if you have any questions, you can ask those questions and I can address them.
Okay. Miss Wilson,
Yeah.
Chandrika is here. Her mic's just not working.
Oh, okay. I don't see, oh, I do. I'm so bad with the chat. I'm sorry. No, you're good. Are you okay? Chandrika, you doing okay? I'm in the chat now, so if you just give me a thumbs up or something. Okay, all right. Thanks.
The due date, the chapter 2 review says it's on Thursday at 8:30 for me.
Yeah, I gotta fix it because I copied it from yesterday's classes, so it automatically takes on their due date and time, so that's something I gotta get used to in Canvas. But I've got a note to change it, so as soon as I can get into my main computer, I will fix it.
Okay, thank you.
Mm-hmm. Gabriel, you okay?
I'm not sure about 17. It's not showing up for me.
It's not? Okay.
Did I download the wrong document? There were 2.
It should be a PDF. Let me see. 16, 17. So 17 has a bunch of limits on there. So you don't see, can you see what I'm showing you right now for 17?
Yeah, I'll just take a screenshot of that. Thank you.
Okay, you don't have that on your document?
I'm on doc, I'm not on PDF, so it might just be the document, not the PDF.
Because this is PDF too. It's kind of weird. Do you all have a number 17 if you're using a computer? Can you see it okay? Really? Okay.
I'll just download the PDF.
If he's on the document, it's kind of like, it's not. If you go on the document instead of the PDF, like, the
Okay.
document is missing like a lot of.
Yeah, all right.
Questions don't make any sense.
So you just have to
Use the PDF.
Oh, okay, yeah, I'll
I
take
put
this.
both of them because I know a lot of Mac users can't see the math on the docs, but apparently, yeah, there's an issue with that. Okay. So I'll remove that document.
Oh, okay, yeah, these questions make a lot more sense.
Remove doc. See, and you didn't even tell me. You didn't say, Ms.
I was
Wilson.
looking at it, wondering, what am I supposed to do? And I just skipped it. It didn't make any sense. And I was just like, I guess I don't know.
You should have
Number
asked.
one, just suppose.
Yeah, he says, list the label.
Yeah, imagine, suppose. So you just ponder that. Suppose. And we're not going to do E on number 18, remember? Green and purple go good together. A purple. Purple's my favorite color. But only certain purples, not all purples. I'm sorry. Yeah, you can use your calculator, but nice work with the limit. Yeah, you can use your calculator. No. So I know, these reviews that the publisher makes, he doesn't say, calculator / non-calculator. I can tell you by looking at it, I can give you an idea of what the calculator / so for instance, if we just start with number 14, that's definitely non-calculator. Now, in 16, that could be a calculator or a non-calculator because you know how to find the derivative the long way, right, using the limit. And then you would plug your 0, your 1, and your 2 in. So everybody, I think, can do that okay. And provided that your derivative's correct, then you wouldn't have a problem. But if your derivative's wrong, then all your answers would be wrong.
So if we have suspicion that it could be non-calculated, we should just try it.
You should always try to do everything without a calculator. But I know, for instance, in number 17, you're going to have to use a calculator on some of those. You don't have a choice at this point. Later on, you won't need a calculator to do it. But when I took calculus, and it was not in high school because I'm so old that calculus was not offered in high school. So I took it in college. And I went through almost 3 full semesters other than using a scientific calculator to do arithmetic. I still have my notebooks, did everything without a calculator. Yeah, and the nice thing is that, for instance, like I remember you'd have one homework problem and it would take up 4 pages of your notebook because it was so lengthy to do it without a calculator. And now you can have all these crazy functions and you can get it done in 2 seconds because the calculator can do so much more for you. So, the calculator is a good thing. The graphing calculator is. The scientific or any calculator is good for the arithmetic. But number 17, there's a couple you could do without a calculator, but, well, maybe one. Yeah, there's only one that you could really do without a calculator. Actually, pretty much 14 through 20 is non-calculator. And if I go back further from the beginning of this review, I don't think you need a calculator for any of them. Well, number 10, you would need a calculator for.
For a test, is it gonna be calculated or you have like?
You have 2 parts generally.
So for all our tests in here, it's we have 2 parts.
You have a calculator and a non-calculator portion. Now, I'm not sure how I'm going to do that with kids taking tests online. I mean, I can watch them, and I will, to make sure they're not like using a cell phone or notes or whatever. But it just seems like it might be a little crazy to try and do 2-part tests during this blended learning. So I don't know how I'm going to approach that yet. All I know is I want to give you guys a test. And at this point, you do have to rely on the calculators quite a bit. So for example, the majority of this review is a calculator is not going to help you. So your test is going to resemble all of these concepts. So I'll just probably make it let you'll use the calculator, but your test will resemble more of this format. And then after this chapter, oh, the calculators, they are no more. Oh, I think I've got a chat message in here. Let's see. Zoom. Chat. No. All right, so kids online, it's 9:57. The bell's about to ring. So you can go ahead and log off and we'll see you on Thursday. I hope it stays nice, cool, and breezy outside and that the wind chimes sway and ring for you. And those of you stuck in the 4 walls of this brick and mortar institution, I hope that you get to go outside and enjoy some of that fresh air, and I hope it stays cool. If any of you work in a metal shop, you should make wind chimes all over the school. I think there's nothing prettier than the wind making the chimes ring. Might. Yeah. I actually bought one for a student once, and it's here somewhere. It has her name on it. Because when I taught at Hillsborough is a very old school, and the windowsills are actually the original wooden windowsills from when that school was built, which was like in I forgot the year now, 19 something, 20 something. Anyhow, so I would tell her, I say, Juliana, get that cup, because she went to Starbucks every morning. I'm like, get that cup off my windowsill. And I said, you know what, I'm going to go to the store tonight and I'm going to buy you a coaster. I'm going to put your name on it. And I did. And I put it on the windowsill and she'd put her Starbucks drink on there so it wouldn't leave a ring on the windowsill. So I have one here and I'll let you use it. But it says Juliana on it. And I don't know where it is. I know it's here somewhere. Bye, guys.
Excuse me, Miss Wilson.